Early 1943, Kummersdorf, proving grounds south of Berlin. Germany's top tank engineers, the minds behind the formidable Panther and Tiger, gathered around their latest prize, a captured American M4 Sherman. They expected a crude machine, a product of a nation of car makers, not warriors. Their task was simple: dissect it, find its flaws, and confirm Germany's technological superiority. But as they unbolted the first panels and peered inside, they didn't find what they were looking for. They found something that, to these masters of complex engineering, made no logical sense at all. This is not another story about which tank was better. The endless debate over guns and armor misses the real, far more terrifying discovery made by those German engineers. What they found inside the Sherman wasn't just a weapon, it was a strategy. A different way of thinking about victory itself. This was the true battlefield of the Second World War, a collision of two opposing industrial philosophies. And it raised the ultimate question: is a modern war won by the most advanced weapon or by the system that can produce and sustain an endless supply of merely good enough ones? To grasp the depth of their shock, we must first understand the world they came from. The doctrine that forged the most sophisticated tanks on the planet. To the German High Command and its engineers, the tank was not merely a tool of war. It was a declaration of national genius. Theirs was a culture of the Meister, the masterpiece. Every machine was expected to be the absolute pinnacle of its class, a triumph of over-engineering where no detail was too small, no solution too complex, if it achieved a superior result. This wasn't industrial production in the modern sense. It was craftsmanship on an armored scale. Consider the Tiger tank. Its reputation was built on its thick armor and powerful 88mm gun. But the true story of its design was hidden in the welds. The hull plates weren't simply joined together. They were cut with intricate steps and keys like a colossal metal puzzle, interlocking to provide immense structural integrity before a single weld was even laid. This process was time-consuming, expensive, and required the highest level of skill. Each Tiger hull was less a product of an assembly line and more a piece of industrial sculpture. This pursuit of elegant complexity reached its zenith with the Panther. Its most defining feature was the shock taloff, an interleaved road wheel system. A cascade of overlapping wheels gave the Panther an exceptionally smooth ride and low ground pressure, making it a stable gun platform. On paper, it was a brilliant solution. In the field, it was a mechanic's curse. On the Eastern Front, mud and ice would pack between the wheels, freezing solid overnight and immobilizing the tank. And a common combat repair, like replacing a single damaged inner road wheel, required the maintenance crew to first remove multiple outer wheels, a grueling, hours-long process under constant threat. This philosophy extended to the heart of the machine. The custom-designed Maybach engines were powerful, high-performance marvels, but they were also temperamental and required a level of maintenance more suited to a race car than a frontline weapon. Every component was designed to be the best, but in isolation. The result was a system of breathtaking sophistication, where one failure could trigger a cascade. This created the most lethal tanks on the battlefield, but it also created a strategic trap. Production was slow, repairs were complex, and the entire war machine was becoming dangerously dependent on a handful of exquisite, irreplaceable weapons. For the engineers at Kummersdorf, this was not a design flaw. It was the necessary cost of excellence. To them, complexity was the signature of superiority. They believed this was the only path to victory. And armed with this conviction, they turned their attention to the captured American tank, ready to analyze its crude simplicity. Then they opened the Sherman's engine deck. What they saw defied every principle of German tank design. Instead of a bespoke, liquid-cooled V12 engine nestled perfectly into the hull, they found a monster. A massive 9-cylinder radial engine standing upright, its cooling fins exposed to the air. This was the Wright R975 Whirlwind, an aircraft engine. To the engineers from Maybach and Porsche, this was heresy. An air-cooled engine in a cramped armored hull was horribly inefficient. It was bulky, forcing the entire tank to be taller, creating a high, unmissable silhouette on the battlefield. It was a crude, almost laughable compromise. Their initial assessment was likely one of scorn. This wasn't a tank engine. It was a piece of aviation equipment clumsily shoved into a steel box. But then, the initial derision gave way to a cold, creeping dread. One of the analysts would have pulled the production files. The Wright R975 wasn't some desperate last-minute adaptation. This engine was a pre-war design already being mass-produced by the tens of thousands for America's training and transport aircraft. The Americans hadn't wasted a single day designing a new, perfect tank engine. They simply took a proven, reliable engine they were already building on an immense scale and designed a tank around it. The realization was staggering. This wasn't a technical compromise. It was a strategic masterstroke. This single discovery reframed the entire equation. It suggested a logic so alien, so brutally pragmatic that they had to know more. If this was their approach to the very heart of the machine, what other heresies had they committed in its construction? With the engine bay still open, the true nature of their investigation began to shift. The shock of the aircraft engine wasn't just about a single component. It was a key, unlocking a new and terrifying language of design. If the Americans were willing to make such a brutal, pragmatic choice for the tank's heart, what other assumptions had they discarded? The engineers moved their attention from the engine to the body. Their eyes traced the lines of the Sherman's hull. To a German expert, it was an offense. Where their Panthers and Tigers featured thick, flat, expertly welded plates of rolled, homogeneous steel, plates interlocked with the precision of a master watchmaker, the Sherman was different. The upper hull was a single colossal piece of cast steel. They could see the telltale signs of the foundry, the slightly rounded edges, the subtle surface imperfections. Their initial judgment was swift and damning. Casting was faster, but it created brittle armor. It was known to shatter under the impact of a high-velocity shell, rather than absorbing the energy. It was, in their expert opinion, a crude and inferior method of construction. Weak. But then the industrial calculus began. One of the men, perhaps from crop or man, would have started the grim arithmetic in his head. To fabricate, machine, and weld the interlocking hull of a single Tiger tank required thousands of highly skilled man-hour. It was a bottleneck that dictated the slow, deliberate pace of Germany's entire Panzer production. Now look at this American hull. A mold is made. Molten steel is poured. It cools. A single complex shape is produced in a fraction of the time. It doesn't require a master welder, just a foundry, and America had hundreds of foundries. The weakness of the cast armor wasn't an oversight. It was a deliberate sacrifice. They had traded absolute quality for overwhelming quantity. The German engineers were looking at a tank designed not to be invincible, but to be innumerable. The sense of unease deepened as they began to unbolt the components. They started with the suspension. The Sherman used a vertical volute spring suspension, or VVSS, a series of bogies, each with 2 road wheels attached to the whole. When a wrench was put to the bolts holding the first bogie, it fit perfectly. Then they moved to another bogie further down the hole. The same wrench fit. They tried it on bolts for an engine access panel for a storage box. The same standardized fasteners over and over. For engineers accustomed to the German system of custom fitting, this was almost incomprehensible. On a Panther, parts were often machined and filed to fit a specific tank on the assembly line. A road wheel from one Panther might not fit perfectly on another. But here, everything was interchangeable. The true revelation came when they simulated combat damage. If a Sherman's bogie was damaged by a mine, the doctrine was not to repair it in the field. The maintenance crew would simply unbolt the entire unit, the springs, the wheels, everything, and bolt on a brand new one from a supply truck. The job could be done in under an hour. They thought of their own Panther with its elegant, overlapping road wheels. A beautiful design for a smooth ride, but a curse on the Eastern Front. Replacing a single damaged inner wheel meant first removing several outer wheels. A backbreaking job that could take half a day in freezing mud. The Sherman wasn't designed for elegance. It was designed for uptime. It was a machine built to fight, break, be fixed, and fight again, all in the same day. This philosophy of brutal efficiency reached its apex with the power pack. They had already seen the radial engine, but now they analyzed how it was integrated. The right engine and the transmission were designed as a single, modular unit. With a field crane, an American maintenance crew could disconnect the drive shaft, unbolt the unit, and lift the entire 2.5-ton power pack out of the tank. They could drop a new one in, reconnect it, and have the tank moving again in less than 4 hours. The same job on a Tiger with its finely tuned Maybach engine nestled deep in the hull was a depot-level task. It could take 2 days, required specialized heavy lift equipment, and could only be done far from the front. The German engineers realized the terrifying implication. For every one of their disabled Tigers, waiting days for repair, the Americans could have the same Sherman knocked out and returned to battle half a dozen times. They weren't just fighting the tanks on the field. They were fighting an army of ghosts, repaired machines that endlessly returned to the line. Finally, they turned their attention to the crew compartment. And here they found the most alien concept of all. They noted the surprisingly large escape hatches for the driver and co-driver on the front glassy plate. They analyzed the commander's vision coupa and the simple functional layout. Then, on later models, they discovered the wet ammunition stowage. The 75mm shells weren't just sitting in a dry rack. They were stored in containers, surrounded by a jacket filled with water and ethylene glycol. The purpose was immediately obvious. If a shell penetrated the hull and hit the ammunition, the fluid would quench the fire, preventing the catastrophic explosion that incinerated so many tank crews. This wasn't a feature designed to make the tank win a fight. It was designed to help the crew lose and survive. A bailed-out crew was not a defeat for the American Army. It was a resource to be preserved. Those 5 experienced men would be taken back behind the lines, given a hot meal, and assigned to a brand new Sherman rolling off a ship. For the German war machine, losing a veteran panzer crew was a devastating blow, a loss of years of training and combat wisdom. For the Americans, it was a logistical problem to be solved with another tank. This wasn't a war of machine versus machine. It was a war of attrition for the most valuable component of all, the trained soldier. The German engineers now understood they were not looking at a poorly designed tank. They were looking at a perfectly designed system. A system where every engineering choice, the cast hall, the standardized parts, the modular engine, the crew-saving features served a single, terrifying strategic purpose to sustain relentless, overwhelming, and continuous combat pressure. They had dissected the machine. They had understood its soul. But they were still missing the most obvious clue of all, one hidden not in a blueprint, but in the simple measurement of the tank's width. They had deconstructed the machine, and in doing so, had deciphered its soul. But one final set of figures remained, sitting on the page, seemingly arbitrary. The Sherman's raw dimensions, its weight of just over 30 tons, its width of 2.62 miles, its height. To the German mind, these numbers made no tactical sense. They weren't optimized for European railways or bridges. They seemed random, an afterthought until one of the analysts, perhaps a man who'd once worked in the Hamburg shipyards, made a connection. He would have cross-referenced the tank's data, not with another weapon, but with the specifications for the standard American cargo vessel, the Liberty ship. And there it was, the numbers aligned with a chilling precision. The Sherman's width allowed 2 tanks to fit perfectly side by side in the ship's cargo hold. Its weight was calibrated to be just within the lifting capacity of a standard dock crane in London or Liverpool. This was the ultimate revelation. The Sherman wasn't designed to be the ultimate tank. It was designed to be the ultimate piece of military cargo. It was a single standardized, shippable unit in a vast logistical machine that stretched from the factories of Detroit across an ocean and onto the shores of Europe. They weren't fighting a better tank. They were fighting a better system of delivery. This realization transformed the equation. It was no longer an engineering problem. It was a mathematical one. And the numbers were terrifying. The final report landed on the desks of the German High Command, not as a celebration of intelligence, but as an audit of a coming apocalypse. The ordnance officer began, as expected, with the Sherman's weaknesses. Its armor was too thin. Its high profile was a gift to German gunners. Its 75mm gun was inadequate against a Panther's Glackus plate. The generals in the room nodded. This confirmed their core belief. German engineering was, and always would be, superior. But then the officer turned the page. He presented a different set of numbers. Not muzzle velocities or armor thicknesses, but production figures. 1 Tiger for every 25 Shermans produced. 1 Panther for every 50. He spoke of the standardized parts, the ease of repair, the chilling efficiency of the Liberty ships. Then came the final soul-crushing calculation. For every 1 Panther that Germany could painstakingly build, test, and transport to the front, the Allies could build 50 Shermans. And if German gunners managed to knock out 10 of those Shermans in a battle, American logistics would tow them back, repair them with interchangeable parts, and have at least 5 of them back on the line by morning, ready to fight again. A heavy silence fell over the room. The generals were suddenly confronted with a truth more terrifying than any new weapon. The war would not be decided by the perfect machine. It was being decided by an endless, regenerating tide of good enough ones. The tactical problem of defeating a Sherman was simple. The strategic problem of defeating the system that created it was impossible. The myth of German superiority had just collided with the simple, brutal arithmetic of the American factory floor. And so we returned to Kummerdorf and the image of that captured American tank under a gray German sky. The engineers had meticulously dissected the machine. But what they had truly uncovered was a philosophy. They looked for a weapon and found a logistical component. They expected a challenger to their steel predators, but discovered a single replaceable gear in a vast trans-oceanic engine of war. They saw a tank full of compromises and judged it tactically inferior. They failed to see that the entire machine was the ultimate expression of a single, ruthless strategy. The Sherman didn't need to beat a Panther one-on-one. It only needed to be there in overwhelming numbers, repaired overnight, and manned by a crew that survived to fight another day. The German pursuit of the perfect weapon had collided with the brutal mathematics of industrial attrition. America didn't build the best tank. It built the system that made victory inevitable. The German engineers had devoted themselves to creating the perfect weapon. They never understood that they were not being defeated by a better tank. They were being overwhelmed by a better system, an industrial machine that treated victory not as a matter of engineering genius, but as a problem of simple, brutal arithmetic. Back.